Good day, everyone. Our topic for today is number theory. We are going to talk about Wilson theorem, pseudo primes, and Euler's theorem. Let's start with Wilson's theorem. It is stated that p minus 1 factorial mod p is congruent to negative 1 mod p. Take note that p is prime number and mod is modulo or remainder. For better understanding, I will give an example. Let's say our p is 7, so we have 7 minus 1 factorial mod 7 is congruent to negative 1 mod 7. 7 minus 1 is equals to 6, so we have 6 factorial mod 7 is congruent to negative 1 mod 7. 6 factorial is equal to 720 or 720. So we have 720 mod 7 is congruent to negative 1 mod 7. 720 divided by 7 is equals to 102 remainder 6. So from the formula, negative 1 mod 7 or simply 7 minus 1, we can get 6 as remainder. Let's have another example. Let's say we have 11 factorial mod 13 is congruent to negative 1 mod 13. From that given formula or equation, we can say that 12 times 11 times 10 until we reach 1. From our general formula, we can say that 12 is equals to negative 1. So we can replace 12 as negative 1. So now we have negative 1 times 11 factorial mod 13 is congruent to negative 1 mod 13. Divide both sides by negative 1. We now have 11 factorial mod 13 is congruent to 1 mod 13. Now we have another formula, which is p minus 2 factorial mod p is congruent to 1 mod p. Let's try this formula using p equals to 7. So we have 7 minus 2 factorial mod 7 is congruent to 1 mod 7. 7 minus 2 is equals to 5. So we have 5 factorial mod 7 is congruent to 1 mod 7. 5 factorial is equal to 120. So we have 120 mod 7 is congruent to 1 mod 7. 120 divided 7 is equal to 17 remainder 1. Therefore, we conclude that our formula is correct. That if p is a prime number and p minus 2 factorial mod p is congruent to 1, which is the remainder mod p, or the given prime number. Now, let's proceed with pseudo primes. According to Fermat's little theorem, if a raised to p minus 1 divided by p, the remainder is equal to 1, or we can say 1 mod p. Take note that mod is modulo or remainder, p is prime number, and a is any integer except 0. Here's the example. Let's say p is 5 and a is 2. So we have 2 raised to 5 minus 1 divided by 5. 5 minus 1 is equals to 4. So now we have 2 raised to 4 divided by 5. 2 raised to 4 is equals to 16. So we have 16 divided by 5, and it is equal to 3 remainder 1. Therefore, we conclude that a raised to p minus 1 divided by p, the remainder is 1. We can now proceed with Eulers' theorem. According to Fermat's little theorem, a raised to p minus 1 divided by p, the remainder is 1. What if our divisor is a composite number? For example, 5 raised to 52 divided by
85.
85 is a composite number. What should we do? First, we must make our divisor as prime number by factoring it. So 85, the factor is 5 and 17. So now we have 5 raised to 52 divided by 5 times 17. We can cancel 5. So we now have 5 raised to 51 divided by 17 is congruent to 1 mod 17. To solve this problem, we need to divide 51 by 16. So we have a remainder of 3. Now, our equation is 5 raised to 16 quantity cube is congruent to 1 mod 17. Based on our general formula, 5 raised to 16 is equal to 1. Then we have 5 cubed divided by 17 is congruent to 1 mod 17. 5 cubed is equal to 125. And 125 divided by 17 is equals to 7, remainder 6. Now we have 6 mod 17. Take note that we divide 5 at first step. So we need to multiply 5 in the last step. So 6 times 5 is equals to 30. So our final answer is 30 mod 85. Therefore, 5 raised to 52 divided by 85 is congruent to 30 mod 85.